Hello people, welcome back to my channel. So today in this video we'll be seeing a Python review or example of the naive Bayes classification, that is the algorithm. So I've discussed naive Bayes algorithm, or the basic routine of the steps and how we can make use that for classification. But today in this video I'll be giving an example. This is not a model building activity, but just a small simple calculations from a simple data set, how we can make use of for the classification. So we'll see some of the formulas and how actually it is done. So basic calculations that we'll be seeing in this. Okay, so I have the pandas. Then this is my data set, that is db.csv. So this is how my data set looks like, and let me just clear the outputs. Okay, so this is my data set, and in this data set first we have to count how many attributes are there. So in this data set we have three different attributes, and the last one, that is defaulted borrower, that is the column. And so you have homeowner, which is a categorical attribute, that is a binary valued categorical attribute. Marital status, which is again a categorical attribute, but it has three values. And annual income, which is a continuous valid attribute. So we have to basically use a different formula, that is a Gaussian estimate, in order to make use for classification. So numeric values or numeric columns are handled in that way in Bayesian classification. Okay, so first let us count for the homeowner. So here I am making a dictionary. In this I have defaulted borrower, that is yes, and it basically in homeowner I have this separation, that is homeowner in yes. How many yes class does it belongs to? So you can see there is no single record, so that's why it's 0. And homeowner yes, and defaulted borrower no. Homeowner yes and defaulted borrower no. 1, then 2, and then 3. So likewise you do the classification. So this is a distribution table of how the instances are separated in that particular class. So for marital status also we have the same way. So this becomes very easy in Python when you want to look how the proportion is there, and you'll also get to know the Python counterpart for simple examples how you can solve this. Okay, so this is how it is done. And for the annual income, this column, that is continuous value, we make use of this Gaussian estimate. So this is the formula that we'll be using. Okay, so for that first we need to have mean and standard deviation for that annual income. So mean for the defaulted borrower yes class is given as mu is equal to, so these are the values for defaulted borrower yes, that is 95, 85 and 90 divided by 3, we get 90 as the mean. Standard deviation is given by square root of summation I runs from 1 to k xi minus 90, because we have given a test record for us to classify. So our problem statement is like we want to classify an unseen example. So the test sample comes in this way. It has the homeowner no, marital status is married, and income is equal to 90. So that's why we are keeping this values here. Okay, so that is xi minus mu. So mu we keep it as fixed, that is 90, and we calculate the standard deviation, that is 5. Then mean for defaulted borrower for the no class, it is this calculation, we get it as 110. For defaulted borrower no class, the standard deviation is around 54.5. So that is basic calculations you'll get to know when you look at the dataset. This is simple calculations, just keep in mind of the square root, and also you have to take the estimates, so that should be accurate. So here we are taking the unbiased estimate. So when you calculate the square root or the standard deviation at the denominator, you will have n minus 1. So n minus 1 will be for unbiased estimate because you are already taking that sample. So since you already have one sample, that is 90, so you'll be falling short of one sample. So that's why an unbiased estimate, that is n minus 1. So similarly here you have 7 samples, but in standard deviation calculation you have n minus 1, that is 7 minus 1, 6. Okay, so this two things you have to keep in mind. So we plug in these values to for this classification with mu and sigma. So we estimate the probabilities for income 90 and defaulted borrower yes as 0.08. For defaulted borrower no, we get as 0.007. Very low probability. So now comes our record for classification, and it asks naive Bayes algorithm, where should I classify this, to defaulted borrower yes class or the no class. Okay, so first what I do is I'll do a routine without handling the zero conditional probabilities. So hope you know, whenever the frequency of one particular attribute or count becomes zero, the entire probability when it gets multiplied, that probability turns out to be zero. Okay, so for that I have probability of defaulted borrower y and given the sample. So this is a conditional probability. So how do you read this, or how do you interpret this probability, whether it belongs to defaulted borrower yes class, provided I already have the sample. Okay, so this is the evidence that you have. So it's given by probability of homeowner no given yes, marital status given yes, and annual income given yes, and this thing is the class prior. So this comes from the normal Bayes theorem, and there in the denominator we have a value that is the evidence. So we are currently skipping that value because we need not have that value. Okay, so we can take out this and we'll determine the maximum value out of this. So that gives our probability value. So you plug in these values into this, and since because one of the value was 0, therefore this particular instance is classified or it belongs to 0 probability. Next we take that same thing here with respect to the no class. Here it should be no class. Okay, and we multiply it, we get a non-zero value 0.0016. So in this scenario where we didn't handle any zero conditional probabilities, since you have only one probability that is greater of the no class, now it is classified as defaulted borrower which belongs to no class. Okay, now what we do, we handle the zero conditional probabilities by using the Laplace transform. Okay, so the same record, when it is classified using the Laplace estimate, so what you do, you do the smoothing. So the basic formula is you add 1 and you divide it by the uh, unique values of that particular attribute. Okay, so when you treat for Laplace estimate, you do for both the classes, whether it's for yes and whether it's for no. Irrespective of that, you do the classification. So this is how it is done. So this formula remains the same. Okay, so this is the previous probability. So if you look here, when you compare this thing with this, okay, so numerator and denominator first terms remain the same. To numerator we add a 1, okay, and to the denominator we add 2. Why? Because this first one, that is homeowner, takes two values, that is yes and no. So that's why the number of unique values you keep it as 2, multiplied by the next one, that is we have the marital status married, and divide by 3. So in the numerator you add 1 and denominator you add a 3, because in marital status you have 3 unique values, single, married and divorced. So that's why you add a 3, multiplied by this probability, that is from the Gaussian estimate, and multiplied by the class prior. Okay, so this thing you should not forget, otherwise your calculation would be wrong. So you estimate a probability of 0.0032. So once you did for yes class, you have to treat for no class also. Regardless, there is no zero probability, but you still have to do. It's not like you do only for the class where it has zero probability. It's not in that way. You treat for both the classes. So in the similar case, 4 by 7 was the original. You add a 1 to the numerator, denominator you add a 2. Here the same thing, plus 1, just here you have to add 3 and multiply it by 0.07 into 7 by 10. You estimate the probability. Now when you compare, the probability of the yes class turns out to be greater as compared to the probability of the no class, and therefore it is classified as yes. So that's why whenever in a data set, if you have missing values or zero frequency problem, you always have to do Laplace smoothing, else it will be misclassified in one sense. Okay, so well, that was all regarding a simple Python review based upon the naive Bayes classification. So hope you guys enjoyed this video, and if you found this video informative, educative, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.